What's up everybody, welcome to Civic. In this video we are going to look at the problem D from today's Codeforces div to round 671. It is called Sage's birthday. You can read out the problem statement. Let me explain it in my own words. So it is Sage's birthday and he wants to go out for shopping, and he would be buying ice pairs, only the cheap ones, which are termed as cheap. So we have been given an array of integers, and these values represent the price corresponding to each ice pair, that is pi, and Sage will only be buying the ice pair which is cheap. And how we be finding that whether ice pair is cheap or not? So it has been stated that the ice pair would be called a cheap one if the ice pairs on both of its sides are having greater price than the price of this middle ice pair. Suppose this is pi, this is p1 and p2, then p1 would be greater than pi as well as p2 would be greater than pi. Only then we can call this ice pair as cheap. And then Sage will go out for shopping and he will buy all these cheap ice pairs. So initially we are given this array, and we can rearrange all these values such that Sage buys the maximum number of ice pairs as he can. And it has been mentioned that the first ice pair and the ice pair present at the last, that is at the index 0 and basically at the left hand and at the right hand, cannot be termed as cheap ice pairs. Okay, so let's see what we can do. I just solved it using sorting. So I sorted my array of prices. Then what I did was, suppose this is my array. So the ice pair which is cheap should be present in between two other ice pairs having greater prices. So what I've done is, I first sorted my array of prices, then I kept on placing the price list from index 1. That is, suppose my array after sorting is a1, a2, a3, a4 till an, and it has been sorted. And I kept placing it here a1, then I skipped one index, and then a2 here, a3 here. So I'm placing it in increasing order of their values. And after, if I have reached to the end of my array, then I start again and then place the remaining elements. Let's say this is the way where I can place it. Then I only checked all these indexes, or you can say all the elements present at even position. If I am considering this as even position, that is second, fourth, sixth, and I'm checking all these elements. If the value a2 is less than a5 as well as a2 is less than a6, then I'm terming it as cheap and adding 1 to my count. Count basically tells me the maximum number of ice pairs Sage can buy. So as we have placed them in increasing order, we would be seeing that the elements which I have written in red, a1, a2 and a3, would always be lesser than equal to the elements a4, a5, a6 and 7. So this is the way where we can maximize the combinations such that we can have maximum number of cheaper ice pairs. That's all we needed to do in this problem. This solution will work for both the versions, the easier one and the harder one. So let's see the code now. Yeah, first I've sorted my array, then I have stored the answer in some other array. You could have done it in the array itself, the input array itself, but I have used some other array. Then I sorted it. Then from index 1 I kept on placing the elements, skipping one index in between. Then for the rest of the elements I filled the remaining elements, that are the A4, A5, A6 and 7. After that I checked all the elements present at this position. The element which is where I am putting the red elements, I checked all the places, and if this condition is satisfied, that is its price is cheaper than the prices of both the adjacent ice pairs, and I just do count plus plus. At the end I'm printing them. So yep, that's all for this video. I'll be seeing you in the next video, where I will come up with the solution of problem C, if I'm not wrong. So yes, okay, take care till then, sayonara.